The following presentation outlines the manufacturing procedures of allopurinol 300 mg for a batch size of 500,000 tablets. We were tasked with streamlining the recipe of allopurinol as well as manufacturing equipment. This led to a discussion of our changes in order to accommodate an increased batch size. Allopurinol is known to inhibit the production of uric acid in the body. Increased levels of uric acid can lead to kidney stones and gout. Additionally, many cancer medications can also increase this level. Dosage forms of allopurinol include intravenous powder through injection, as well as oral tablets. The oral tablets use the method of immediate release. The tablets come in both 100 mg and 300 mg dosages, but for the purpose of this presentation, we will be discussing the recipe and equipment changes for the production of 300 mg tablets. Tablet production can be broken down into 5 stages from start to finish, starting with synthesis, then granulation, lubrication, compression, and finishing with packaging. Allopurinol is the active pharmaceutical ingredient in these tablets and first needs to be chemically synthesized before it can be combined physically with other ingredients in the manufacturing plant. The process starts off with the combination of malonitrile and hydrazine hydrate with the use of deethylation to create 3-aminopyrazyl 4-carbonitrile. This is then hydrated with carboxamide combined with the condensation of formaldehyde, which yields allopurinol. The following materials are needed in addition to the allopurinol to create the rest of the tablets. Quantity has been increased to account for the batch size of 500,000 tablets. The next 3 steps in processing include granulation, lubrication, and compression. We will go into detail about certain manufacturing equipment we chose for all of these steps. The process begins with granulation. The allopurinol, lactose, povidone, FD&C yellow No. 6 lake, and starch are set inside a mixer, specifically the Sigma Model 300, due to its size capacity. The mixture is then amalgamated for approximately 15 minutes, allowing there to be a homogeneous mixture. The material is introduced into a 250 micrometer sieve aperture screen. This step helps identify and segregate any unwanted large components. The material is then added back into the mass mixer, followed by the addition of water. The amount of water can vary, as long as proficient hydration takes place, allowing a structured aggregate to form. Then, a 2 mm aperture screen on an oscillating granulator, specifically the Tapasya oscillating granulator, is then utilized. This particular oscillating granulator operates at an output rate of 400 kg an hour at about 180 oscillations per minute. Therefore, this step takes approximately 45 minutes. Next, the aggregate is dried in a tray dryer at about 50 degrees Celsius until only 1 to 2% of the total moisture content is present. The product then runs through a 595 micrometer aperture screen on the Tapasya oscillating granulator for approximately 45 minutes once again. This model of the oscillating granulator is useful as many different screens can be interchanged for several purposes, i.e. the 2 mm aperture screen versus the 595 micrometer aperture screen. Polyethylene lined drums are then utilized to hold the material and seal it until it is ready for the next step in the process. These images outline the equipment used in granulation, including the mass mixer, aperture screen, oscillating granulator, as well as the storage for the material in the polyethylene lined drums. From here, the dried granulated material is ready for lubrication. Coming from the polyethylene lined drums, the granulation is placed into a vertical cone blender. From a separate input, crossed Carmelos sodium and dried starch pass through a 595 micrometer screen before being added to the blender as well. The mixture is amalgamated for 15 minutes. Then, the material is transferred back into the polyethylene drums, where it is sealed and weighed for storage. The following images align with the process of lubrication, showing the vertical cone blender as well as the micrometer screen. The last step in formulation is compression. The product is placed in a stainless steel input hopper, which feeds the material to the main part of the press. Tablet formation occurs when the powder is fed into a lower die punch and compressed by an upper punch controlled by a main compression roll. The die system works simultaneously with the punch and shapes the tablets to correct shape and thickness according to specification. Once completed, tablets attach to the upper punch and are deflected by a takeoff blade to a discharge chute. For this particular tablet, 11.11 mm diameter concave punches with a bisect on the top portion of the tablet is needed. Once the tablets are completed in compression and collected in the discharge, they will be packaged into various types of containment. For this batch size, bottling the tablets in high-density polyethylene containers is more efficient and cost-effective than blister packaging. An automatic counting packing system is needed adjacent to the rotary tablet press, where the tablets are fed into a stainless steel hopper. The system is equipped with packaging speeds ranging from 500 to 1,000 tablets a minute, and is completely automatic, so tablet filling is customizable to the bottle size. Overall, we aim to keep the chemical integrity of allopurinol while increasing the batch size to 500,000 tablets. We achieve this by increasing the overall raw material as well as selecting machinery for appropriate capacity. In return, this will cause greater efficiency for the processing plant and will overall lower their price of production. Allopurinol 300 mg is also most importantly used for cancer patients undergoing chemotherapy. By decreasing processing costs, the overall cost of the medication should decrease for patients as well, yielding benefits for both production and patients. Thank you for viewing our presentation of the analysis of the production of 300 mg allopurinol tablets for a batch size of 500,000 tablets.